Hi, this is problem 52 of Neetcode 150, lowest common ancestor in binary search tree. Alright, so we are given a binary search tree where all the nodes value are unique. And we are also going to be given two nodes called P and Q respectively. We're going to have to return the lowest common ancestor of both nodes. An important point is that the ancestor is allowed to be the descendant itself. So let's just clarify this point with an example. Let's say that we are given 3 and 4. Well, what is the lowest common ancestor? Well, 3 itself can be the ancestor. So you can return a value that is P or Q, right? As long as it is the lowest common ancestor, it is fine. All right, so let's look at this example. I think it will be pretty self-explanatory. So we are given P and Q. P is 3, Q is 8. So right there, you can see both. And what is their lowest common ancestor? Well, it's 5. All right. So let's try to visualize how we can solve this problem. So basically what we know from a binary search tree is that starting from a node, all the value to its right will be greater than that node value, and all the value to its left will be smaller. So one thing that we are pretty much sure of is that if one value, so if P is smaller and Q is greater, well, it must means that P lies to the left and Q lies to the right. So we are sure that the lowest common ancestor is going to be that 17, right? Okay, so this is something that we can say for sure. Okay, but now what if both are greater? What do we do? Well, if both are greater, why can't we just set our current pointer to the value to the right? Okay, so what if now we point to 35 and we restart the problem with 35? So we know that if, for example, our P was 29 and our Q was 38, well, now we can be sure that the value is 35 because we know that one values lies to the left and the other values lies to the right, so we can return 35. So this is basically going to be the entire logic. I don't think there is any other edge cases than that. We can start coding this. So first we are going to create a value to keep track of the root so we don't override the root. So let's call it the pointer. So the pointer is going to be the root, and after this we are going to use a while loop until we no longer have a current. So in this problem we are sure that there is a solution, so we don't have to handle the edge case where the values P and Q are not inside the tree. So I will use the while loop while there is a point here. And now basically if both values are what if both values are greater than the value at the pointer? So what if the nodes is smaller than both? So that will be checked the following way. So if so if P the val is greater than the value at that pointer, and also Q the val is greater than the value at that pointer. All right, so if this is the case, well, we are gonna set the pointer. We're just gonna move everything to the right. Okay. And same thing here. So what if, let me just rewrite this entire logic because it's exactly the same. So now what if the value of the P pointer is actually smaller, right, than the value at the node we are looking at? And what if the value at the Q is also smaller than the value at the pointer we're looking at, this is where we know that both values lies to the left of that node where the pointer is pointing at. So we are going to say that the pointer is going to be equal to pointer.left, right? And now what else can we think of? Well, I can think of what if basically the pointer itself is either P or Q, or what if P is smaller and than the node and Q is greater than the node, or Q is smaller than the node and P is greater than the node? Well, I think that in all these statements, we can be pretty sure that we are currently pointing at the lowest common ancestor. So let's um, let's submit this problem and see if it works. And there you go. All right. So I hope you learned from this video, and I hope to see you in the next one.